Integration by parts can be tricky to master, so we're going to work through these examples relatively slowly to see where these different parts are coming from and how we're completing this process. So the first thing we want to do is look at our integral expression. We're integrating 3x e to the 2x. So if we go back to that idea of Liate, which helps us choose our value for u, the first thing we're looking for is a log function. We don't have any of those. We skip I since that relates to trigonometric expressions. And then A is algebraic. So 3x is an algebraic expression. So that's what we want to substitute for u. Whatever's left in our problem becomes what we substitute for dv. So in this case, dv is going to be equal to e to the 2x dx. So just like we did with integration by substitution, we're going to take the derivative of both sides of this statement for u to get du over dx equals 3, or du equals 3dx. With our dv statement, we're going to integrate both sides. So on the left-hand side, really, if we think about this, we're integrating 1 dv. So since we're integrating with respect to v, this integral becomes v. Then on the right-hand side, we need to integrate e to the 2x, which would require integration by substitution. So let's introduce a little bit of a shortcut for integrating something like this. So the integral of e to the ax dx. So we've got x being multiplied by any number. We could use substitution, get that result, but as a shortcut, which we'll be able to use in this class from now on, is that will integrate as 1 over a e to the ax plus c. And you could demonstrate that by integrating that using substitution, but it'll always come out to be something of this form. So in this case, we have the integral of e to the 2x, meaning this will be 1/2 e to the 2x. So we have u, du, v, and dv. So now we want to construct something of the form u times v minus the integral of v du. So what we're going to do is take the different pieces that we've substituted or found. So u is 3x times our value for v is 1/2 e to the 2x. So we're not integrating this portion. This is literally just taking our expression for u times v, and then minus what we will have to integrate is v, so 1/2 e to the 2x so v and then du times 3dx. So we can rearrange this a little bit. This will become 3x over 2 e to the 2x minus the 3 times 1/2 is just a constant multiple. So minus 3/2 times the integral of e to the 2x dx. So now we're down to just integrating e to the 2x, which we could do with substitution, or again, take advantage of this formula that we just introduced. So our result here will be 3x over 2 e to the 2x minus 3/2 times, this integral will be 1/2 e to the 2x plus some constant c. So just simplifying a little bit here, we get 3x over 2 e to the 2x minus 3/4 by multiplying those two fractions together, e to the 2x plus some constant c. So all of this is contingent really on getting these substitutions set up correctly. So obviously that becomes a very important part of this process. In example 2, we want to start off the same way. To get that substitution for u, we want to think of that expression liate again. In this case, we do have a log function, so we'll let u equal the natural log of x, which means du will equal 1 over x dx by taking the derivative of both sides and multiplying that dx across. Everything that's left becomes our expression for dv. So in this case, x to the 10th dx. Integrating both sides of that, we get v equals x to the 11th over 11. So now we can set up our expression in that same form. We want u times v, so we want the natural log of x times x to the 11th over 11. So that's our u times v minus the integral of x to the 11th over 11. So this is our v times du, so times 1 over x dx. So what will happen here is the 1 over x will simplify with one of the x's in the numerator to make that x to the 10th. So we'll get x to the 11th over 11, natural log of x, so just reordering the multiplication there, minus the integral of 1 over 11, or minus 1 over 11 times the integral of x to the 10th dx. So this is going to integrate as x to the 11th over 11 plus c. So we end up with x to the 11th over 11 times the natural log of x minus 1 over 11 times 1 over 11 will give us 1 over 121 x to the 11th plus some constant c.